And we're ready for example number 6 with literal equations. All right, so we have this formula that a photographer perhaps could use. I have to admit it's probably programmed into a camera nowadays, but this is to find the amount of lighting they would need for a particular situation. L, luminance, lighting. I'm out of my realm. I should stop talking about the background. Stick to math. Let's solve this for F. All right, so again, we would rearrange that formula. And so here we are with literal equations. Clear fractions, yes. Let's multiply both sides by the denominator, st. And so we've got st being multiplied on both sides. Over here, we're just distributing. Alphabetical order, L, S, T equals, all right. Over here, over 1. You knew I was going to say that. You said it with me. I heard you. But that st would cancel that st and just leave the numerator 25f squared. So that's what's meant to, by clearing fractions. F, let's note, is only in one term. So all we need to do is use inverse operations to isolate that variable. And, again, the idea would be that in the order of operations, in reference to f, you would perform the exponent, then the multiply by 25. Notice that the multiply by 25 is further down the list. It's the further operation. So we're left with LST divided by 25 equals f squared. And then, of course, you guys know that to get rid of squared, we would introduce square root. I got the square root, but I did not get infinity. Bob Mathley, you guys remember that one. Okay, so anyway, that leaves f equals this. And again, typically, it would not be wrong, but let's switch the two sides around just so we have variable equals. If a photographer needed to calculate by hand the f-stop on their camera for a particular scenario, that would be the formula to do so. So I guess that's the end of that. I miss you guys. I hope this is making sense to you, and I guess we'll find out. Hang in there, everybody.